The seaweed that washes up on our beautiful Pacific coast looks perfectly normal here. And of course it is. We don't like it when too much of it litters our beaches, but usually if we are walking along, we hardly even notice it. Hi, I'm George Page, executive producer of Nature. This week, our filmmakers will take us out there, under the surface, to tell the fascinating and important story of this seaweed. These are pieces of giant kelp, also called macrocystis. In fact, this slimy stuff represents a tremendous natural resource that someday may be as important to man as the offshore oil. The unusually severe winter storms that occurred here in California during the winter of 1982 and 83 caused damage not only to the homes and businesses built along the water's edge, but also to the underwater plants that normally grow here in great profusion. The sheer force of the storms did enough damage to the beds of giant kelp, but a recent warming of the ocean has hurt them as well, because this kelp grows best in cool water. In fact, the kelp beds are in trouble. Along some parts of California's coast, as much as 90% of the plants were destroyed by the storms, and it will be years before they grow back. Our film was shot before the violent weather did its damage, so we can share with our filmmakers the magic of this underwater world and begin to appreciate the growing importance of this weed in our lives.
Ours is a slippery, smooth world. Much of what we use or eat must pour or spread with super slick perfection. An essence of smoothness, algin, a panacea for those who seek to thicken, emulsify, extrude, and gel, can be found here in some of the weeds of the sea. The seaweeds, or kelps as some are known, are algae, some of the oldest plant forms on Earth. They bloom in many forms off many coasts, and though unnoticed by many of us, they've been exploited for centuries. But just how important they really are is only slowly being revealed. Off the coast of California, big business is getting into the largest of these submarine forests on a grand scale. But like the forest of the land, there's more to the wood than just the trees. There's an amazing animal community here. The very existence of the kelp forest seems to depend on such animals. In places, the exploitation of these creatures has produced dramatic changes to the detriment not only of them, but ourselves. Land forests still sweep to the edge of the ocean from which they once emerged. But where their roots stop short, another forest system takes over below the surface. On the west coast of Canada, the only hint you might get of the existence of this other hidden watery woodland is what might be taken for just so much floating rubbish. bladders and fronds of a forest of elk kelp, where the underwater breezes ebb and flow with the tides, and where what looks like a flower is quite likely to get up and walk. And unlike this sunstar, there are flower-like animals that do not move. The sea pen and the sea anemone sit tight as toadstools, but in their case, waiting to catch a meal on the breeze. And these are not the tendrils of some super climber. It's another anchored animal on the grab. That's a mouth at the center of this basket star, not the anthers and stamens of some exotic blossom. But while it's fun to compare the grasping legs of barnacles with the petals of flowers and to marvel at the feathery blossom extruded by a tube worm, it's worth observing that it's these anchored animals that are one of the unique features of the undersea forest. On land, their place would be taken by other plants. These bushes are sea cucumbers. They can move. The bushy bits are tentacles used to wipe any food that sticks to them across the mouth in the middle. There are snails here as on the land, but bigger and dressier. This is the abalone, or ear shell, a shellfish that loves the kelp and grows to considerable size by browsing on it. They're less dramatic snails rasping away, but in normal times there's enough to go around, as none stops in any one place long. And there are snails without shells, the delicate nudibranchs, slugs of the sea, but with all the gaudy beauty of butterflies. Beauty is no protection against the hunters in these forests. The colorful, spiky sea urchins are good eating for the fierce-jawed wolf eel. And the hunters are not always swift, even if on several hundred tube feet. The abalone makes off on 1 foot, but has a deft way of shrugging off this attacker. Eat and be eaten is the rule of the game here, and kelp is at the heart of the system. The kelp crab is among the vegetarians who exploit the seaweed's food value. The decorator crab has other uses for it. It dresses up in the variety of weeds to be found in the undergrowth of this kelp woodland. The cut and chewed fragment is deftly fixed into minute hooks on the shell of the crab. It's a painstaking business, and when completed, the crab's outline will be quite disrupted. So the kelp is not only food for millions, but a hiding place for a whole community. It's a community of great diversity, and as we're learning, one of subtle relationships, of checks and balances between the hunters and the hunted, and the kelp itself. It's as intricate and fragile as any forest on land. California, some 600 miles further south from those Canadian shores, and a short distance offshore, floats the tangled roof of one of the largest and most controversial submarine forests in the world. From this huge forest come not only seafoods and most of America's algae needs, but research being done here could one day lead to a powerhouse, feeding energy to the whole United States. The giant kelp, Macrocystis, is the largest of seaweeds. Each huge plant is anchored to the seabed by what's called a holdfast. Unlike a tree, the kelp has no buried roots. This many-fingered organ's function is mainly to grip and restrain the tug of the giant above. The bulk of the plant consists of fronds bearing several hundred leaf-like blades, each buoyed up by a gas bladder and carried on the long, flexible stipes of the fronds growing up from the holdfast. The speed of growth is phenomenal. New blades spring from the old. Battalions of bladders filled with carbon monoxide gas seem to tug the plant on its upward journey. The stipes between the bladders will elongate and may stretch the whole frond 200 feet or more, growing sometimes as much as a foot a day. Having no roots, the only nourishment the plant receives is from sunlight and from mineral nutrients in the ocean. The surface of each blade is able to photosynthesize, and the foods produced are passed down from the better lit canopy to the lower blades and the holdfast, where some are stored. The fastest growth is along the surface, and the tangled canopy closes over, darkening the forest floor more than 100 feet below. Dampening the waves to a gentle swell, kelp burgeons in the sun. You can almost see it grow. But these giants do not stand alone. This forest is far from empty. Huge shoals of fish find refuge in the kelp beds, over 100 different species. These blacksmiths may even be using the giant kelps as signposts, orienting themselves in certain feeding positions. Although no species of fish may be completely dependent on the kelp for survival, the forest permits them to thrive in greater numbers. The kelp bass has a distinct preference for kelp, and its young use the shelter of the blades as a hiding place and feeding ground. It's perhaps as a fish nursery that the kelp forest is most important. The whole plant is alive with other animals. Its fronds provide living space for a vastly greater population than could otherwise exist. There are those, like the kelp snail, who browse over it, rasping at both the kelp itself and whatever is settled on it. And there are those, like the barnacles, that clutch at the surrounding water, filtering out their food. A sea hare, another mollusk but with its shell inside, motors up and over the fronds, browsing like the snails. And like them, it'll drop off to begin the climb all over again. Although so many creatures cluster on the kelp, they're often hard to spot. The principle that you are what you eat has made the kelp crab particularly cryptic. A juvenile spends its salad days safely hidden. And some fish have found it an advantage to be kelp-like while hanging about for a meal. plain or mottled, the kelp fish's flesh can assume the color of its surroundings. In so rich a hunting ground, it's not surprising that kelp fish come quite large. This one's about 1.5 feet long. A single frond of the giant kelp is mature in about 6 months. By then it can be laden with many hundreds of tiny animals. They may look like plants, but they are indeed animals. Those red bushes are colonies of an animal called bugula, and those white patches are colonies called membranipara. Certainly theirs is a sheltered life among the kelp blades, and most aren't eating the kelp, but by being anchored here in the passing breeze of the current, particles of food are swept to them. All they have to do is reach out from their tiny homes and grab them. And such sitting targets are easy prey for browsers. About 100,000 creatures per square yard jostle to exist on these fronds. Worms and tubes compete for space with the animal bushes, and crustaceans pick a meal off them like birds after berries. The skeleton shrimp hides disguised as a bush and, like a mantis, can clutch at passing plankton. Younger versions pick at the bugula, while the adult fans her eggs. The bugula gets bitten by a variety of mouths, but even those who pick on the bushes will get picked on in their turn. The sea slug Polycera has left a telltale slime trail, and Navinax, a relative of the sea hare, is in hot pursuit. One down, but it detects another trail. The flamboyant Flabellinopsis, another sea slug, likes these bushes too, and is unaware of hungry Navinax as yet. Will Flabellinopsis meet the fate of Polycera? No, Flabellinopsis has one last-minute trick. The Spanish shawl, as it's commonly known, flips off to browse another blade, assuming it's not caught on the wing. Down at the base of the kelp, a turban shell begins the long climb back up. The blades of the kelp here may also be releasing the microscopic spores of the kelp itself into the plankton to drift away and ultimately initiate the growth of new kelp plants in the forest. Like the blades, the holdfast, too, is home for many animals. The interstices are festooned with life, and deep within an old holdfast, the burrowers will have been at work, in time loosening the grip of the whole organ. There's plenty to feed on, and a young octopus can grapple its way through a meal or two within. Brittle stars, too, can insinuate themselves into the system. A kelp plant may live 10 years, so the holdfast must grow constantly to hold firm. Down here, an assortment of creatures eat the kelp itself. Potentially most damaging are the sea urchins. The purple urchin and the red urchin, which is edible, compete for grazing room. Both varieties cluster in crevices and feed on fallen blades, but they can turn to eating the living plants, and too many of them can weaken the holdfast's grip. The threat posed by the urchins is only one of the storms brewing around the future of the kelp forest. Giant kelp to survive these conditions, it has to be tough yet flexible and strongly anchored to withstand the great surges produced by storms. But a powerful storm can break the kelp loose, as can the burrowings of mollusks and worms, or the grazing of urchins and others. The starfish have lumbered over to grab the fruits of the storm, a shower of snails. Some will escape, but others will be digested out of their shells as the starfish envelops them with its stomach. On land, dead trees lie where they fall. Here, such giants leave the forest. They are cast up here to rot on the beach. But little is wasted in nature. The drifting fragments of kelp leaves will fatten the urchins and in turn the lobsters and others who will prey on the urchins. These are teeth that need to be controlled. Huge abalones join in the feast. They also have a share in this forest. The abalone's competition apparently curbs the numbers of urchins. Day and night, kelp changes into abalone meat, a fat snail that, like the red urchin, is also a delicacy for us. The fecundity of such creatures of the sea should mean that there's enough for all. The abalone's profligate scattering of eggs would seem likely to overrun the world with abalones. Sex is a casual affair with abalones. The male, sensing the proximity of an egg-laying female, starts about fertilizing those eggs. But the meeting of egg and sperm is left to chance. The fertilized eggs develop rapidly to swimming larvae, and in a very short time, those that haven't been gobbled up by fish will settle to start life as tiny abalones. But they may have drifted for about 10 miles or more while in the plankton. It takes an individual about 8 years to grow to full size, and once upon a time there were indeed thousands of them. What happened to them? We ate them. The turn of this century was boom time for abalones. They were fished from the sea in uncountable numbers to satisfy a gourmet fad. It was a cataclysmic commercial plunder, and all the more surprising when you remember it's just a snail. They collected and dried them for canning by the million. No one could foresee that one day the boom would go bust, any more than they could imagine that the sardine would vanish from this coast. But it did, and the day would come when the abalones would also decline. And yet the coastal Indians here had fished the abalone as a basic food and for its valued shell for thousands of years, as well as the other creatures of the sea. Mackerel by the ton, fish that perhaps grew and fattened around the kelp forest. To some fishermen, just another of those inexhaustible resources there for the taking. But if the catches are poor and the fish run out, someone else usually gets the blame. The fishermen are licensed by the California Department of Fish and Game to fish these waters, and they expect that department to make sure fish are there for them to catch. The same department licenses those who want to fish for lobsters, crabs, and, when they were abundant, abalones. The department must satisfy its customers' needs, but it's also charged with protecting all species, particularly endangered ones. And in the kelp forest, that has put them in a catch-22 situation with this creature, the sea otter. About the size and weight of a German shepherd, the sea otter is the smallest marine mammal, but in the northern hemisphere, the biggest of the otter family. Its life is inextricably bound up with the kelp. Clowns of this forest, they've caught the hearts and minds of thousands who've watched them frolic as they feed. Lawmakers, both state and federal, have had them on and off their lists of endangered species in response to the lobbying of conservationists and the protest of fishermen who see the otters as competitors rather than allies. The sea otters have probably been eating urchins ever since their land-based ancestors took up living among the kelp, and they were sucking the insides out of starfish when only the Indians shared these waters with them. In those days, it would seem there were enough leftovers for all. And the sea otter was a natural control by day and night on the numbers of urchins eating the forest. They also love abalones. In those earlier forests and offshore, they learned the techniques of tackling these great snails. But to a would-be abalone fisherman, this sight is a horror movie. They blame the decline of abalones on the otter. Apart from abalone, some 49 other seafoods are on the otter's menu, though not fish. For more stubborn urchins and more obstinate shellfish, the sea otter has an even better trick. It uses a large stone as an anvil on which to crack open a meal. Animals that use tools in this way are a small and exclusive club. Underwater, they sometimes use the stone as a hammer to loosen abalones, or as a diving weight. Keeping it warm and waterproof is a coat of fur more dense than any other marine mammal. Sea otters have no thick insulating layer of body fat, only the fur that requires constant preening and cleaning to keep it groomed and full of trapped air as insulation. Some think the fur traps water and insulates like a wetsuit. It's that fur coat that has also been the otter's greatest liability. To the fur hunters of the 18th century, the pups and mothers and the rafting communities of sea otters were riches afloat. The Indians had taken the furs too, but not like the thousands butchered for buyers in Russia, China, Europe, and the Americas. There was a myth that pups without mothers could take care of themselves, but it was only a myth. By 1911, of the more than 200,000 sea otters between Alaska and Baja California, only a couple of thousand remained. Off California, its numbers had dwindled until it was thought extinct, leaving the abalones to grow and the shellfish industry to boom along a shoreline that steadily filled with people. Not long after, in the mid-1940s, the giant kelp forest, too, began to disappear. Where kelp forest had once grown off the Los Angeles and San Diego County coasts, there was an urchin-ridden desert. The deterioration had begun in areas nearest to major sewage outlets. The urchins thrived on it, and in huge numbers grazed out the seaweeds. Furthermore, the giant kelp prefers cool water, so its deterioration was hastened by an influx of warm oceanic water that persisted off the California coast from 1957 to 1959. It might be happening again. In just over 20 years, the kelp forest had vanished from a substantial stretch of the California coastline. One of the first reactions was to protect what kelp forest remained. Sport divers were encouraged to eliminate kelp grazers. Urchins were slaughtered indiscriminately, and kelp-eating fish were speared and trapped. These efforts did seem to halt the decline. The divers were acting rather like the absent sea otters and holding the balance. But tip the scales in any direction and something will win or lose by the change. It could only be a temporary solution. What was needed was more information about the natural processes essential to the very existence of the forest. Scientists of government departments, the universities and institutes, together with commercial kelp harvesting companies, got together on an intensive kelp research program. One plan was to try to restore the kelp forest to selected areas. Divers set about eliminating the urchins, again doing the work of the absent sea otter. Today, with the kelp beds so weakened by storms, the urchin is an even greater threat. Vacuum dredging is being used in some parts as well as hammering. Here, a shoal of senoritas takes advantage of the divers' handouts. In the 60s, when they first tried it, it didn't work, but several years later it did. Water conditions had changed enough to allow giant kelp plants to settle and grow. The natural settlement was enhanced by bringing in new plants from existing kelp beds or using laboratory cultured embryos. But only 1 in 100,000 kelp embryos will develop, so several billion had to be introduced for any hope of success. They also tried anchoring larger plants individually by hand. That worked too. They were not trying to replace whole kelp forests, but only to form the nucleus of new beds. The new plants were constantly monitored. In addition to urchins, some 9 other creatures graze the new kelp, and in the absence of sea otters, need a little control by man. The urchins are the worst, but there are some fish that like to eat them. So as the fish population grows around the new plants, the urchin eaters may come in too. Some of the fish are counterproductive and nibble the kelp. When growing conditions are right, the new kelp reaches quickly for the sun, and the darkening canopy closes again over the restoration site. But it takes a long time for new beds to grow as rich and dense as the older forests. Earlier restoration work was successful on a limited scale, and now this kind of work is of even greater importance. We now know that this forest is quite naturally liable to change in overall area and in the number of plants. The change is related to the quantity and quality of light, the temperature and quality of the water, the age of the plants, damage by grazers, storms, currents, and the drift of sediment preventing new plant settlement. Man has a tremendous effect on these forests, pouring in domestic and industrial wastes, flooding them with thermal effluent from power stations, and by the way he uses the kelp itself. From the forest of the land, we crop the trees, often with destructive effects. When the kelp forests are healthy, we can take a little bit off the top, by the ton. Until the recent storms in California, these kelp beds provided an abundant harvest. The giant kelp, wherever it grows, is the world's principal source of algin. The algin that makes mayonnaise pour, paint spread, jellies gel, and keeps the head on beer. Algin emulsifies, stabilizes, and gives plasticity, viscosity, and extrudability. Kelp from here goes to smooth our way of life. Only mature beds are cut, and normally rapid growth would permit 2 or 3 licensed cuttings a year. They mow as accurately as on a golf course. It's a massive pruning, and within a few weeks, some 24 feet of new leafy fronds will grow back on each cut plant. The cutter of kelp must know as much about his crop and its seasons as a farmer on the land, if he's to maintain it. This big business is an ally to understanding and keeping the forests. And there's less of this, the company says. Much of what they cut would have broken off anyway to drift to the shore. Certainly where the forest disappeared, people enjoyed weed-free beaches. And there may be other wealth in this waste. There are useful digestive processes at work here. The creatures of the shore come out of the air and out of the sands to eat and multiply among the wreckage. The drift kelp is the driving force feeding those animals, and the microbial digestion of the kelp liberates methane gas, a process which, if harnessed, could satisfy a major part of the country's natural gas needs. Methane from solar energy via the digestion of kelp. So this waste could be a natural fuel. It's not surprising, therefore, that very well-funded research programs are centered on getting to know these plants. On land, research developed new strains of cereal crops. Here, they hybridize giant kelp. It's long been a dream to farm the giant kelp on a grand but controlled scale in the ocean. Undersea farms covering vast areas. But first, know your crop. Computerize it, measure it. How fast does it grow? How much of its area photosynthesizes? How important is the quality of the seawater? What nutrients does it need and when? And how are those nutrients absorbed from the ocean? The development of scuba diving apparatus in the 1950s opened the ocean to these scientists. They could follow the kelp into the sea. This is the latest technology to probe the secrets of the kelp, the hemidome, an underwater greenhouse. But they'll not be bedding seedlings. Whole giant kelps will be housed in there. From the floating frame, a huge bag is suspended in the ocean, isolating a private pond. Within this pond, kelp plants can be grown and fed under controlled but near natural conditions. These selected plants are hand-picked to match the size at which they would normally be harvestable. The first transplants are anchored in the pond about 4 feet apart. The holdfast are tied to these anchorages. The kelp comes complete with a number of its associated animals, and even in this pond, it will experience the necessary water movement to help it absorb nutrients. The surface water of the experimental area is poor in nutrients, so it's pumped in, and measured solutions of nitrate and phosphate are added. The natural kelp forest grows best during seasonal upwellings of colder, nutrient-rich water from deep down. If kelp is to be farmed in great bulk, it would need more constant and reliable fertilizing along these lines. Excess nutrient-rich water is taken out of the bag and pumped clear of the area. This experimental hemidome project lasted for 1 year. The yield from the plants in this controlled environment will allow scientists to assess the economic viability of a huge commercial ocean farm. If the natural kelp forest can be secured and maintained, there's still the possibility of successful fisheries along the Southern California coast, but not on the former grand scale. The California sea otter, in fact, escaped extinction, and since 1938 has slowly built its numbers to about 2,000. But it still faces illegal persecution by those who are not its friends and who are unable to accept the otter in its natural role as a controller of the forest community, and not just a thief in the kelp. Controversy continues as otter numbers grow. So far, they haven't entered the more southerly kelp forests, and there's no scientific reason to keep them out. The otter will continue to eat seafood, including abalones. But for us, abalones can be farmed. They're edible at 2 years old if you're not prepared to wait for 8 years fattening to full size. The abalone population diminished because of man's greed, and because of sheer carelessness. The debris from the building of a coastal highway covered up the best beds with silt. Meanwhile, the California Department of Fish and Game is still in that catch-22 situation, charged with managing and protecting the sea otter from persecution and pollution, yet receiving its income from fishing licenses, and so needing to ensure that there's seafood to be caught. Kelp forest can exist without the otter, though it's an impoverished system. Now the emphasis has to be on restoring the kelp beds themselves. We are just beginning to understand the intricate balance of life in this underwater world, and careful management can provide a natural resource of tremendous potential. The forces of nature have recently caused a great deal of damage. Now, man must continue his work to restore and maintain this forest in the sea.